Year 2021, month of May. Today's video, I will explain the relationship between mathematical notation, APL, and other programming language concepts. So, how are programming languages and philosophers similar? Each language or philosopher influences and is influenced by others. For example, Plato influenced Thomas Aquinas, who influenced Nietzsche, who influenced a modern writer like Slavoj Žižek. These writers would disagree with each other if they could all meet today. But regardless, those in the past influence the present. In programming, there is C influencing C++, that influenced Java, that influenced Groovy, which influenced Clojure. And in fact, since all five of those are still being used, they're influencing each other in kind of a non-linear fashion. Especially the JVM group there, Java, Groovy, Clojure. Groovy and Clojure can innovate, so can Scala, and then Java later on builds some of those features into the core language. In programming, C has had the most influence. APL is not influenced by C. APL is older and is a smaller branch of the programming language family tree. The only influence on APL is not a programming language, but rather mathematical notation. This is core, is that something outside of programming influenced a programming language. Since APL is so much closer to mathematical notation, it can help explore mathematical ideas, or to see how mathematical ideas have influenced programming. And the point I'm trying to get across in this video is that the programming concept of a database is simply to understand a very large but finite amount of objects with various attributes. It is a set. These are usually represented by the column names in relationship database management systems. The programming concept of loops or maps in functional programming is taken from the big symbol notation from mathematical notation. So the sigma, limit, there are symbols for a product that are the giant P. There's giant AND symbols, giant OR symbols. Almost any operator can be made big and then have an operation be repeated. Programming languages, or computers in general, are best at doing large amounts of finite steps. So if I need to get all the sum of a bunch of numbers, the first 10,000 even numbers, or the first 5,000 randomly generated numbers, I will set up a loop which is going to be equivalent to this notation, and I can have the computer just do that. Whenever the ending number, or the limit here is infinite, then computers really struggle. Computers are not meant to really understand infinity the way a human does. You could create a computer algebra system that can, arguably understand the concept of infinity, depending on what philosophy you take on whether computers can understand anything or an artificial intelligence can truly understand anything. But there does appear to be something unique to humans, or to the value given to statements in a logical proof. we're going to have to meet aliens before we really can get that churned out, what that is. So that is my conclusion for this video. The most powerful thing in programming is looping or mapping or simply repeating something over and over, doing a trivial thing fast. And what that is mathematically is sums, limits, any of the big operator notation that is finite, and sets that are finite. Those are the mathematical things that computers excel at. But when infinity shows up, then you need the real human mathematician, philosopher, to know what is the meaning is.